Ladies, earlier in class today, we completed the first goal in section 8.3 through the first half of example B. And we finished up with the nth term formula for a geometric sequence. So we derived that. So let's put that to use and practice using it. Number 1 says write the first 5 terms of the geometric sequence if the first term is 4 and the common ratio is square root of 3. Sorry that's down there. Guess my software got off. Anyway, so remember, with a geometric sequence, we know that we take the first term and multiply it by the common ratio to find the second term. So our first term is 4. Our second term is 4 square root of 3. Our third term would be 4 square root of 3 times the square root of 3, or 4 times the square root of 3 squared, which we know is 4 times 3, or 12. So our first term is 4, second term 4 root 3, third term 4 root 3 times itself, so 12. So our fourth term is, sorry, not 4, but 12 times the square root of 3. In our fifth term, we'd multiply 12 times the square root of 3 times itself. So 12 times 3 is 36, and that gives us our first 4 terms. Example number 2 asks for the 8th term of the sequence whose first term is -4 and common ratio is -2. So we're given just the right information to use the nth term formula. So a sub 8 is equal to the first term, -4, times the common ratio. Now remember, you want to raise this to 1 minus the term you're looking for. So if we're trying to find the 8th term, we'd raise this to the 7th power. So let's calculate that. So -4 times -2 raised to the 7th power gives us 512. So our 8th term is 512. All right, let's look at example number 3. We want to find the 7th term of the geometric sequence whose first term is 5 and common ratio is 3. I'd like you to pause the screencast and try this one on your own, then come back in a moment and check your answer. So to find the 7th term, we multiply the first term of 5 times 3, and we raise that to the 6th power because it's asking for the 7th term, so 7 minus 1 is 6. So that's equivalent to 3,645. With example number 4, it asks for the 10th term of the sequence. And in this case, we know the first term is 12, but we're not given the common ratio. So if we calculate the common ratio, remember we'll take 2 consecutive terms. I'm going to take 3 and 6 because that's easier to calculate. I guess 6 and 12 is pretty easy too. And so we see that our common ratio is 1/2. Please pause the screencast and find the 10th term, then come back and check yourself. All right, so we have 12 times the common ratio of 1/2 raised to the 10 minus 1 power gives us a term that's 3 divided by 128, the 10th term. Let's look at number 5. It asks for a formula for the 7th term of the geometric sequence given here. So let's look at that formula. Okay, I realize that this question does not make sense. You're not going to find a formula for the 7th term because you have enough information to find the 7th term. I'd like you to find a formula for the nth term, and that's going to be the same thing for number 6. So let's find a formula for the nth term of the geometric sequence. Sorry about that. All right, so number 5, we know that we'd use the nth term formula, so a sub n equals the first term times the common ratio. So our common ratio, 36 divided by 3 is 12. And let's also just confirm that 432 divided by 36 is 12. So let's check that. So 436, wait a minute, 432 divided by 36 is 12. So that confirms that for us. We want to raise that to the n minus 1 power. And now we have a formula to find any term. So for number 6, find a formula for the nth term, a sub n equals the first term times our common ratio. And our common ratio, 8 divided by 4 is 2, 16 divided by 8 is 2. So our common ratio is 2, and that is raised to the n minus 1 power. So that's pretty simple, finding the nth term for a geometric sequence.